like to welcome Sheeri Cabral. She is the SheBA team lead for the Pythian group, MySQL consultant stuff, and she is here to talk to you about how to stop hating MySQL and start learning to love the bomb or something.
Something like that.
Yes. So without further ado, and I can stop embarrassing myself.
Thank you, Chris. So yes, as Chris said, this is entitled How to Stop Hating MySQL, Fixing Common Mistakes and Myths. Feel free to raise your hand at any time, asking questions, whatnot. If I don't get to you, write it down. Even if I do get to you, you might want to write it down just so that you don't forget by the time you do that. I reserve the right to say, hey, ask me later. But I'm certainly willing to at least hear all questions before making that decision. And we'll have plenty of time for questions at the end, although I reserve the right to be wrong about that.
Real fast.
Yeah.
For questions, please do use the mic as they're being recorded.
And should you forget to use the mic, I will not only humiliate you, but I'll also repeat your question so that it will actually get to everyone. So who am I? I am a MySQL DBA, or as Chris calls me, the SheBA. That's actually a title that one of my coworkers gave me. It is my moniker because it's catchy and whatnot. Although it's really hard to write out because it kind of just looks like Sheba. I run the Boston MySQL user group, which is one of the more successful ones. And by successful, I mean lots of people come to it regularly, and mostly that's just because we have topics every time that we talk about. I do the MySQL podcast, which is called Our SQL. Right now it's on hiatus because, as I said earlier, I'm writing a book, and I only have so many hours in every day. I have put in a request for more hours in the day, and it just keeps getting ignored. So there are also videos at technocation.org. Which is a not-for-profit website that helps IT professionals, but it's on a donation basis, so it's mostly MySQL because it's mostly stuff I throw at it. And I have done a whole bunch of community stuff. You can't see my shirt probably, but there's the little community MySQL logo and it says MySQL Community Contributor. I've won the MySQL Community Award 2 years in a row, which is, it's cool, but I'm kind of like, there's got to be other people out there. And if you happen to be thinking, oh man, how am I going to write all these links down and everything, if you actually go to pythian.com/blogs, that's pythian.com/blogs, at least for now, there's the first link is how to stop hating MySQL, and there's a whole bunch of links here, including a link to the presentation that I'm about to give. So if you want it, it's already there. You can see into the future. So there are some myths about MySQL, that it uses too much memory, it's slow, it doesn't have more I need features that it doesn't have. Obviously, if you need features it doesn't have, that's a myth that is actually true. But some of them will bust some of the other myths, that it uses too much memory, it's slow. There are also more myths about MySQL that you shouldn't use the enum data type. Now the enum data type is actually a string data type. And what it does is in a field, you can have a bunch of different strings, but they are internally represented by integers. So integers are smaller than strings. Therefore, they're faster to compare and whatever, because if you're comparing 1 byte, it's faster to compare 1 byte than 2 bytes. The problem with enums is that if you need to change what the enums are, so let's say you have a field called status, and this field, the status might be active, inactive, paid user, whatever. If you need to add to that status, you then need to change the table, which locks the whole table, and it can take forever. Hence, the next bullet point is schema changes take forever. That's another thing. If you want to alter a column and change something or add an index, the whole table locks for however long it takes to change every single row in that table. Another myth is that you have to restart MySQL to log, to do the general log or the binary log. And another myth is that MySQL doesn't have partitioning. Now, you might be saying, but those are all true. Well, they are. They're true in MySQL 5.0. MySQL 5.1 is going to come out as GA probably in about 3 weeks, beginning of December, definitely by the end of December. But if you're going to use any of these features, I mean, it's ready now, pretty much. They have a couple of bugs that they really want to get rid of, and I don't see any reason. We already have some clients using 5.1 in production. So I have this other blog post, which is linked from the first one, which is called Why You Want to Switch to MySQL 5.1. So I have the little soundbite of in 2 words, the reason you want to switch is online operations. So they have an online alter table, which you can rename columns, you can change the default column value, and you can add values to the end of an enum or a set. And that happens online, which it doesn't happen now. So that's not all schema changes, are now online, but it's a really, really good benefit. There's online table-based logging, which is really convenient for anyone who's kind of wanted, to see all the queries that come in, but doesn't want to stop MySQL, restart it, get all the queries for a period of time, and then stop and restart it again to turn off the general log. Similarly, if you're not running with the binary log enabled, which is the change log, and you realize you need it running, it can be a pain to have to say, oh, I need to restart my system now. There's also better DB auto increment lock handling, which you can read more about. This is actually a link on the site, so you can do that. And prepared statements now work with the query cache. We'll talk about the query cache a little later. The process list, if you've ever done a show process list and you are ripping your hair out because you're like, I only want to see the sleeping queries, or I only want to see queries where, that have been running for more than 60 seconds. There's an information schema table called process list, so now you can query it and you can say, where time is greater than 60. So that's another reason to use MySQL 5.1 right away. I think that's about it on my list of things, yeah. So those other things are myths no more, hopefully. And there's the URL. But again, you can just go to the site and click through yourself. So let's address the myth that MySQL uses too much memory. You might notice that when you start up MySQL, it takes about 95% of your system's memory. And it kind of like grabs it, but it doesn't necessarily allocate it all. And you can still kind of use it for some other things. There are people that run, Java and MySQL on the same box and live to tell about it. I wouldn't recommend that in production, but some people do it for development. So one of the things that you can do is, in 5.1, you can query the information schema global variables, which is all of the global variables. You might know them as system variables. But they're things like, max allowed packet and all those things that you set in the my.cnf. In 5.0, you can only use the show statement, show global variables, but in 5.1, you have this new information schema table, which means that you can do things like, show me everything from global variables where the variable name is like cache or like buffer. And those are pretty much the memory parameters. So one of the common mistakes that people make is that they actually waste memory. They're allocating memory that they're not using, or they're not able to use the memory that they think they are using. So 2 parameters, BDB cache size and BDB log buffer size. BDB is the Berkeley database storage engine for MySQL. It has been taken out of MySQL 5.1. It's actually a storage engine that's older than InnoDB, and it was transactional before InnoDB was around. There are some people that are still using it. But basically, these 2 parameters are by default enabled, and so you end up wasting something like, it's some small amount, like 8 megabytes in memory, allocating these things. So in 5.0, you can set BDB to be off, and then you don't have to worry about that. Again, it's a very small amount of memory, but if you're dealing with lots of little things here and there, 8 megabytes can help. So the other thing is a 32-bit operating system. The 32-bit operating system has only a certain amount of memory space that it can address. And you can't use probably more than about 2.4 gigs of memory if you do that. And there are people that, they'll go to a hosting company and they'll be like, I want 32 gigs of RAM in this box. And their hosting company gives them the 32-bit operating system for a database server. And yeah, you're laughing, but it actually happens. So the 64-bit operating system, is a must for a database server. So one of the myths is that using the query cache will make things faster. That can be true, but it doesn't necessarily have to be true. If you are caching queries, what happens is, if you turn the query cache to on, which is this one variable, set the query cache to on, it's off by default. If you turn it on, it will try to cache every query. There is a parameter that says, don't cache queries larger than, that have a result set larger than this size. But what happens with every single query is, it takes the string and makes a hash of it, and then compares that hash to a key value paired table. Therefore, if your query doesn't exactly match, if you put an extra space in the middle, or your capitalization is different, it won't actually match. Yeah, it's kind of a hack that way, but it's really important to understand that's how it works, as well as all other kinds of caching problems, such as every query is looked into the cache, whether it may be there or not. There's cache invalidation. Every time you change a table, if there's results from that table, they get invalidated, even if those results haven't changed. Because the table has changed, MySQL doesn't know if maybe the results have been changed or not, so it just invalidates it. There's always the check against the cache, and it's always going to store the results. And so if you have a heavily updated table, let's say a sessions table, you don't really want queries against that to be cached because it's going to change so quickly that it's not worth it. One of the things that I really recommend is using memcached for caching common queries. Another artifact of the way that the query cache works is that it doesn't really cache, it doesn't really compile the query and say, okay, well, you just said where the username is this, you retrieve that, so what about where the username is that? Like every different value is a different query. So one of the things that I would definitely recommend is you want to use memcached. Another thing that you can do if you can't quite convince your developers to use memcached is if you can set the query cache type to demand, which is a query cache type value of 2, what you can do is it will only cache queries upon demand. So when you write a query, you have to write, instead of select from table where whatever, you write select SQL cache, like this little keyword here. And so you write select SQL cache, user host from mysql.user. And what that will do is it will cache that query, assuming the results are smaller than the parameter you've set. So that can be a way to get caching just on the ones you know that are good. Of course, if you can get your developers to change the query to use SQL_cache, then you could probably just change them to have them use it memcached. One of the reasons that people use the query cache and that it does work in some ways is that it's a lot harder to change code sometimes because it has to go through all these QA processes and all that kind of stuff. And, we're just DBAs. We can just change a parameter and we'll be done. It's fine. But if you're really developing a high performance site, you use memcached. The query cache can help. So I wouldn't say never use the query cache, but it can help. But there are also many instances of somebody, turning on the query cache and, everything got slower. I said before that it's turned off by default. By default, the query cache size is 0. So it's not something you have to worry about if you've never touched the system, but it's probably something to go look at. So let's see. Oh, one thing I didn't talk about SQL no cache. So if you have a query cache type of on, and you don't want it to cache the results, you can do select SQL no cache, user host from mysql.user. And what that will do is it will check to see if the result is in the cache. So you still don't get away from that, but it won't cache the results. So if you know that there's a query that's against a table that's always changing, and you have this type of one or on, you can actually say, don't cache the query. I know I don't want to cache these results. All right, so we have a MyISIM index cache, and there's a parameter called key buffer size. I don't know if there's a default value because it's usually in the default my.cnfs, there's always a key buffer size, and the manual wasn't any help. So it's globally allocated upon startup. So that could be another place where if you're not really using a lot of MyISIM tables, the system tables are MyISIM tables, so you can't get rid of it entirely. But if you're not using a lot of MyISIM tables, you might be allocating this buffer that's not really used a lot. So then you can say, well, Sheeri, how can I tell how much is being used? I'm glad you asked. I talk to myself like this a lot. It's usually more disturbing when I'm not in front of an audience. So how much is being used? And you do this by looking at the status variables, which in 5.1, again, you have a table you actually have 2 tables in the information schema, which is the data dictionary, called global status and session status. Or you can just do show status in 5.0 and under. And basically there's 2 parameters, key blocks used versus key blocks unused. And basically you can get a percentage by doing key blocks, unused times the block size divided by the key buffer size. But you can basically compare, how much of it is actually in use versus not in use. I could show you an example, but I have a local database, and right now there's nothing in the key cache size. So I've actually looked at it, and it actually says 0, which means that the system tables are probably using some other cache, or it's a very small amount. So the EnoDB buffer pool, if you're using the EnoDB table type, which many people are because it's transactional, the globally allocated buffer pool is EnoDB buffer pool size, and it allocates that on startup, whether or not you use it. Again, you can look at the status variables of number of pages free versus the total pages. There's also a variable that you can set to say when there's this percentage of dirty pages, then flush them to disk and all that kind of stuff. But basically, this is the important part where you can set the size. Again, if the size is set really high, you can lower it and decrease the amount of memory that MySQL is using. The EnoDB buffer pool holds the data and the indexes. So in the MySQL index cache, it only holds the indexes. The MySQL data files, they just, whatever OS caching it uses, that's just what it uses. There's no cache for the MySQL data, but there is for MySQL indexes. For EnoDB, you have a buffer pool that holds the data and the indexes all together. Now, there are some memory parameters that are allocated per thread. And so per thread is kind of like per connection. I'm not going to go into the difference between connections and threads, but for the purposes of this discussion, they can be the same thing. And basically, whenever you connect to MySQL, and you have a new connection, whether it's your PHP or view on command line, it's going to allocate these parameters. One of the things it allocates is this bin log cache size. And what this is 32 kilobytes. And it's the cache, the memory buffer for the input and output to MySQL. So it starts at 32K, and if you're sending more than 32K of data, it grows. It grows up to max allowed packet. And who here has gotten the max allowed packet error when they send too much data to MySQL? Okay, so what happens is you started at 32 kilobytes, and then you got up to whatever max allowed packet was, and it errored out. So that's also the result max allowed packet. I said it's for input and output. So you also have this bin log cache. So you send a whole bunch of information in, and let's say you're going to get a whole bunch of information. Usually it's one or the other. You send a little bit of information, like a short query, short compared to sending a lot of data, and you get a lot of data back. And so once you send all of the data, it will shrink back to 32K. And then, it'll start buffering the results, and then it will send back the results, and it will grow again up to max allowed packet. So this is another thing that if you have a lot of really short queries, are you really getting back 32 kilobytes of data for every single query you send? Are you really sending 32 kilobytes for every query? If you have 500 connections, do you need to be allocating 32 kilobytes for each connection? Again, you could set it lower. It doesn't necessarily matter because it's going to grow if it needs more. The max bin log cache size is, so the bin log cache size, that's actually per query. The max bin log cache size is per transaction. So if you're actually using transactions where you say begin, and you run a couple of commands, and you say end, the maximum bin log cache size is 4 gigabytes. And it's not actually allocated 4 gigabytes, but it can go up to 4 gigabytes, and that's the default. So you can change that default to smaller. But it will use that amount of memory. So if you have this really long transaction with a lot of data going back and forth, you could be using a lot of memory. If you change this value of 4 gigabytes, then you will end up messing up your presentation there. If you change the value of 4 gigabytes, you'll end up getting an error if you try to go above that. Again, with bin log cache size, if you go above 32, if you go above the if you go above 32 I guess it shrinks and it grows, but there's a point at which it might go to a temporary file. And one of the important things to note about memory use, as well as, is MySQL being slow or not, is that there's a big trade-off between memory and disk I/O. So you can set some caches bigger. If you set your EnoDB buffer pool bigger, then it will cache a lot more stuff. It'll be a little faster, right? But you're using more memory. Versus if you don't, then you're going to be reading to your disk a lot. You're going to have a lot of disk I/O. So there's that generic trade-off. The other allocated per thread buffer is called net buffer length. And what that is it's for the, oh, my bad. So the bin log cache size is 32 kilobytes, and that's per statement. The net buffer length is what I was describing before that goes to max allowed packet, which is your input and output. The bin log cache size is actually per one statement, and if the statement gets bigger, that is when it writes to a temporary file. So so pardon my messing that up. It's the net buffer length is the input and output. And it starts at 1 megabyte and goes to max allowed packet. So the per thread allocated as needed buffers are the join buffer size, which is the memory buffer for the joins that don't use indexes. You probably always want to use an index for a join. There might be times where you can't do that. But you might look at the join buffer size and say, oh, that's for all joins. It's not. It's just for the joins that aren't using indexes. And it's only allocated if you actually need it. So the only way to get rid of that is to get rid of the joins on tables that don't have indexes on that join. The read buffer size is the memory buffer for sequential table scans, and the read random buffer size is the memory buffer for random table seeks. And again, these are used as needed, so you would have to find the queries that are doing these table seeks and table scans and get rid of them somehow by having them do index scans or index seeks. And we have some more here, which are the preload buffer size. It's used when you preload indexes. If you preload indexes, you know you're doing it because there's actually a command to warm up the index caches. And the sort buffer size is for when you're doing sorting by order by or group by. So again, it's allocated as needed, and you would see using file sort in the output of explain. We'll talk about explain later. The MySQL sort buffer size is actually, it's not like the sort buffer size. It's only for sorting indexes, which really only happens when you're doing a repair or an optimize or you're creating a new index. So these are the memory parameters that you can those were all the memory parameters that you can kind of play around with to have MySQL use less memory or more memory. So there's also a few more temporary tables. Basically, there are some values that if you set them high enough, MySQL will do things in memory, and if you set them not high enough, it will write things to temporary tables, which causes disk I/O. So again, it's this trade-off of memory versus disk I/O. Temp table size and max heap table size are the two parameters at which the in-memory temporary intermediate tables in a query will be used. So if you have a query that's dealing with a lot of intermediate results, because maybe it's a multi-join or something like that, or you have a subquery, if the result gets larger than temp table size or larger than max heap table size, it will write that temporary file to the disk, which again will make it slower. Large rows and blobs are always written to disk. So if you have something that's like a tiny blob goes up to 255 characters, which you could do a varchar instead. But if you do a tiny blob, it's always allocated as a separate object, and blobs are always written to disk. So that's about memory parameters so far. Does anybody have any questions or comments or anything about that? Okay. Yes. Yes, please. I tricked you because I asked for it.
When you're talking about the tent table size and the value before it gets written to disk, are you able to tell if it's writing to disk all the time? Like, is that something MySQL can log for you, or you can have like the slow query cache, for example, where stuff gets put there? Is there a way to output that kind of stuff to see if your developers are doing that?
Well, there are variables where you can see how many temp tables are written to disk. If I go here and I do show status like %temp, you can see it says created. Now, obviously, this is an MySQL instance that started up when I started my machine. Can you guys read that? It says created temp disk tables is 0. Created temp files is 5, and created temp tables is 0. So basically, this is the number of in-memory tables, and then the disk tables are the ones that got so big in memory that they got transferred to disk. The other way that you can tell is if you look in the temporary directory or the data directory, depending on what they're doing. If it's like an alter table, things will happen in the data directory. If it's an intermediate table, it will happen in the temp directory, whatever MySQL sets as temp dir, which would be show variables like temp dir, and you can see it's C Windows temp. If you see files that start with a # in and usually it's pound SQL dash a number. That's a temporary file. So you can see what they're doing in the status variables in MySQL, and you can also see if it's happening, right now by looking on disk. We had a problem where one of our clients was saying, I'm getting this error, and the error was something like table corrupt, and the table that was, try to repair by, running repair table, and the table that was corrupt was like this temporary table, pound SQL, whatever. So I asked them what query they were running, and they were running a query, and it basically, the temporary table ate up all of their available disk space, which was like 20 gigs of disk space. This is a really crazy query. And it ate up all their disk space, and so then couldn't go any further because it was still trying to put more stuff, and the query died. So the temporary table was corrupt, and the query died. And so it set this error. So it was this weird kind of error, but if you get an error that involves like a pound SQL table, that's a temporary table. So, did that answer your question? Excellent. Any more questions? All right. So there are some variables that are kind of caches, but they're really kind of for performance. They're not really using tons of memory. One of the things is one of the system variables is a table cache. And what the table cache is it is a number of, I just want to make sure I got this right, it's a number of file descriptors that you allocate to open tables, because each table is a file on the system. Even if it's an enodb table, there's a .frm format file. So every table needs a file descriptor to be open. One of the ways that you can see if your table cache is big enough is see if the status variable opened tables is growing. Every time MySQL opens a new table, it increments that status variable. So if your table cache isn't big enough, which basically you want it to have one for every table you have. So if you have 100 tables, you want your table cache to be 100 or like 200 or something. And again, it's just a cache of file descriptors, so it's not very big. But it can be something that if you're constantly, closing the file and getting rid of the file descriptor and then opening it again, that can be a lot of overhead. That can really, slow down your system. And thread cache size is a cache that when you connect to, again, connections and threads, when you connect to MySQL, it will have a connection thread cache. It's different from like a connection pool, but it does have some of the same overhead of opening and closing it. So this is not a connection pool, but it's a similar kind of concept where if you have a thread cache that's big enough, you eliminate some of the overhead in connection. And if you want to check to see if your thread cache is big enough, you look at the status variables called connections versus threads created. And you compare the number of connections that have been made the number of connections that have been made since the MySQL system started, and then threads created is the number of threads that have been created. So if that keeps growing, you want to make your thread cache larger. So size matters, as they say, as we were talking, bigger is better. And bigger actually isn't necessarily better. If you have more data, or if you have fragmented data, if your data takes up more space, whether it's valid because it's all data, or it's fragmented, it's going to use more memory. When you put that data or that index into memory, it's just going to use more because it's bigger. Same thing with disk space, right? But disk is cheap. But if you're searching through it, it takes more time to search through. If you're going page by page, it takes more time to look through a bigger book than a smaller book. That's common sense. But what that means is you want to make sure that your data is as small as possible without limiting you. But there are people that they just use big ints for everything, or they use varchar 100 for everything. And you can say, well, it's variable length. Why does it matter if I use varchar 255 or varchar 65536, which is the limit? It's actually 65532, but we don't have to get into that. But if you do 65532, the reason the limit is 65532 is that there's overhead involved. And there's 3 bytes of overhead if you use that much, or 2 bytes of overhead, plus there's 2 bytes of overhead to determine how long it is. So if your varchar is only going to be, maybe 20 characters long, you don't need to have a varchar that's so big it's going to take 2 bytes of overhead to see how long it is. Similarly with integers, if you say, well, I'll just use big int for everything. Well, if you use big int for everything, integer goes up to about like 4 billion. Do you really need more than 4 billion users? Do you really think that you're going to have more users than half the population of the Earth? Probably not. So, and the difference between a big int and an int is that a big int is stored in 8 bytes, and an int is stored in 4 bytes. So that's like double the amount of stuff. And again, when you're comparing, 4 bytes, 8 bytes, who cares? When you're doing a lot of transactional stuff, that really can be, a common mistake people make is they just big int for everything. Let me just cover all bases. So, you want to do that. You want to make sure that you defragment your data. When you can actually tell how fragmented your data is. Let me actually do a query here. And so if you go to the information schema, which is the data dictionary, as some folks may know, and you go to the tables table, you can see that it's got things like here's the database, and here's the table name, and here's the table type, and all that kind of stuff. But there's also fields called data length and index length. And those tables are exact values for MyISOM tables, and they are approximate values for InnoDB tables. So one thing that you can do is you can say, show me the table length, the data length and the index length, add them together for each MyISOM table, and then compare it to the size of the .myd file and the .myi file on disk, and see if they're fragmented. Because the length of the data is the actual length of the actual data, not including any fragmentation, and obviously what's on disk includes fragmentation. So you can see how, if you don't have a sense like, oh, I'm doing a lot of leads, so there's probably a lot of holes in the data, if you don't have that sense of, oh, let me optimize it, then you're going to end up with fragmentation, and here's how you can check. InnoDB is approximate, but obviously if the values are hugely different, probably it's defragmented. In order to do that with InnoDB, you either need to take all the InnoDB files and add them together and compare them to the IB data file, if you're not using InnoDB file per table. We recommend using InnoDB file per table, which will create one .ibd file, one data index file for every single table. Which, can kind of be annoying because you have all the .frm files and all the IBD files. But it's actually really useful because another benefit that you get when you optimize that table and defragment it is you get that space back in your disk. So if you have a, 10 gigabyte IB data file, and you only have 9 gigs of data, when you optimize that table space, if you're just using, regular InnoDB, you're not using file per table, you don't get that space back. The file itself is defragmented and things will run more smoothly, but you don't get that space back on the disk. With InnoDB file per table, you do. So size matters. Another thing that you can do is, yes, question?
InnoDB file per table, do you have to dump and restore your data?
So the question was, if you turn on InnoDB file per table, do you have to dump and restore the data? The answer is pretty much yes. Basically what you can do is, when the InnoDB file per table flag is set, whenever an InnoDB table is built or rebuilt, it will make it file per table. But if you want to reclaim the space from your IB data file, then yeah, you need to dump and restore. One thing that has been useful for people that have really huge, things that are kind of, we actually just did this for a customer that had 300 gigabytes worth of InnoDB files, and I think saved about 50 gigabytes by, doing that. First of all, that will defragment it because you're rebuilding the tables. Another thing that you can do is you take a replicant slave that perhaps you're using for disaster recovery, and dump and restore on that. So that's InnoDB file per table. Promote that to your master, and or take a hot backup of that, and then restore that hot backup on, but by hot backup I mean a consistent backup and copying the files, and then restore those files to the master. So it is a pain, but the architecture of MySQL is such that it can be done relatively, they can be done painfully on a non-production server, and then you promote that non-production server to a production server, and then things are better. Another thing about choosing the size of your data, if you have a lot of, say, users and you delete users, again, make sure to purge users. You might want to archive them to a different table before you purge them, so you still have the data there if you need to ever get it back, do reporting or whatever. But if you have some kind of user table, do you really need to keep all those deleted users that aren't, logging in because they've been deleted for years now? You don't necessarily need to keep them in the table, the active table, because again, even though, the table might not be fragmented, there's a lot of data there. And so to search through it, it's not really useful. So try to keep your data sizes smaller as well as your actual amount of data as small as possible. And of course, you don't want to screw yourself by making it so small that you end up having to change the table later. So it's kind of where it's an art versus it's a science. EnoDB uses clustered indexes. And what that means is that it actually clusters the primary key with every single index. So if you have a primary key on, say, a number or, a varchar 100, because you'd like to put varchar 100s in tables. People do this a lot. If you have that, it will actually be clustered with every single index, even if it's not the primary key index. It's actually put in that index. So that's another reason to keep your primary key small, especially on an EnoDB table, so that it's going to be mixed in with every single table there. Similarly, MySQL cluster also has clustered indexes, and it will also, the way MySQL cluster works is if you don't have a primary key, it'll make one for you, and will just make basically an auto increment. So if you are using MySQL cluster, the NDB storage engine, you might as well put an index of auto increment that you can use, because you can't actually access the internal one, because it's going to make it for you and you're going to use the space anyway. So I think that's everything on that one. So how often do you optimize? We get people like, oh, we want to defragment our data. We should do it like every day. In my experience, I found, let's see, some very high fragmentation kind of applications, such as, I forget what the open source answer to DoubleClick is. I think it's Open Ads or something. I was working at an online dating site that had used this Open Ads, and they basically had tons of this stuff. And we noticed that the reporting on the Open Ad stuff was getting doggedly slow. And we're like, oh, we should optimize it. We said, well, we optimized it. And we figured like a year later we need to do it again. It ended up being about 25, 26 days later that the reports were getting slow again. So even on this hugely, like every time somebody clicked somewhere or whatever, we were doing 3,000 writes per second and another 3,000 reads per second on top of that. So it was a very high, and that's on one machine. We had 10 machines. So it was a very high usage site, and we still only had to optimize basically about once a month. So we optimized it once a week just to be sure. So don't think you need to optimize your tables daily. Most, I would say, normal sites, maybe once a month, maybe, probably once every 6 months or so. If you're this huge high, if you're Facebook, you probably need to do it once a week. And again, purging and archiving regularly just to keep your data size small. And it's also probably better for compliance. That way, if somebody ends up stealing your data, they only steal part of it. And anytime you do a large delete, you want to optimize it. So put your data on a diet. You also want to put your schema on a diet, as I was saying before. Some other tricks that you can do for IP addresses, instead of storing the characters, 192.168.1.1, there are some handy functions in MySQL, inet underscore a to n, which is, it looks like aton, but it's address to number, and that will store it as a 4-byte integer, because all IP addresses are just integers anyway, right? 0.0.0.0 is the integer 0, and 255.255.255.255 is, 4 to whatever, 4 billion, whatever that number is. Actually, I can show you here, because I have the technology. That's annoying. I actually just wanted to see the bottom. Here we go. If I do, select inet a to n of 0 to 0 to 0 to 0, inet, say, a to n of 255 strings, we're working with strings here. And say inet a to n of, say, 192.168.1.1. And we get, 0, 4, 2, 9, 4, whatever, and then something I can't actually read, but it ends in 7. There, 3, 2, 3, 2, 3, 7. So basically, you're taking something and making it completely non-human readable, right? But with A to N, and with also with N to A. So one thing I can do is I can do select inet N to A, which is number to address of a number, which should be. Have I mentioned I hate Windows yet? I do. And now I get 192.168.1.1. So using those functions, you can actually make, a long character string of, 3, 6, 9, 12, 13, 14, 15 characters long into something that, is 4 bytes long. Now, how long is a character? It's 1 byte if you're using the Latin 1 character set. It can be up to, 3 or 4 bytes if you're using, UTF-8, if you're using UCS-16, all that kind of stuff. So you could, if you're using, say, UTF-16 or UCS-16, your 15 characters could actually be 60 bytes. 60 compared to 4, 15 times improvement. That's a lot. Another thing that you can do is timestamp versus datetime. Timestamp has more limited range than datetime. Timestamp, I think, starts at the epoch and goes until, I don't know, it's only 2 bytes long as opposed to datetime, which is 4 bytes. But, again, if you only need that small range of data, if it is a true timestamp field, right, where you're just putting in now, then you don't need a datetime. You can use timestamp. And I think we already talked about enum and set versus, strings and numbers. Numbers are usually smaller, strings are usually longer, similar to the IP address argument. If you can use enum and set, I would recommend doing it. One thing that a lot of people do is they'll have something that I like to call joining tables. I don't know if that's the official name for it. But you have something like a foreign key to, instead of having your enum of status, you have a status of 1 or 2. And then you join that to a table and you say, okay, 1 means active and 2 means, paid and 0 means inactive. Instead of doing that, one of the things that you can do is just have the foreign key be to the string, status, active, whatnot. Now that takes longer on insert because you have to check to make sure the foreign key matches, and you're checking to make sure that the foreign key, which is a string, matches. So you're checking a longer string. But that's only on insert, and then when you retrieve it, you don't have to do any joins because what's in there is text. Again, the same kind of concept is there with enum and set, and so with 5.1 using, online, if you just want to add one. If you want to add one in the middle, or you want to add a value of enum in the middle, or you want to remove a value of enum, you still have to wait for the whole alter table to it's not online. But if you just want to add a value to the end, which is what most people want, there's no reason not to use enum. So the myth of yes, question. Either that or he's landing a plane.
If you go back one slide, if you're doing a significant amount of betweens or date comparisons and things like that, is there any benefit to using timestamp versus date time from a performance perspective?
Well, I mean, betweens you're comparing, but I see what you're saying is because it's going to convert it to a date time if you're comparing it to a date time. I guess the answer is probably going to be that you want to make sure that your comparisons are as easy as possible and that you're using indexes for them. If you have a timestamp column because you're actually using the function on update current timestamp, then you need the timestamp column. But yeah, in those cases it doesn't matter because it's going to convert it to the longer datetime anyway. But in those cases, if you're finding a between to be really slow, you might be using some kind of function on it, so we can't use an index, or we'll talk about more of that later. Thank you. So the myth of MySQL is slow. We talked about the memory disk trade-offs. If you have to go to disk more, unless you have some kind of magic machine, disk is slower than memory. That's just kind of how it works. One thing also, we'll talk a little bit about different kinds of table types later, InnoDB versus MyISOM versus in-memory. But the indexing of certain tables indexes differently. So the indexing of in-memory tables is actually hash structure. So it's a lot, every access is a random access in a hash structure. Whereas with the B-tree structure, which is what the indexes are for MyISOM and InnoDB, random accesses are kind of all over the map, but sequential accesses are a lot faster. Whereas if you do a sequential access, like either a range, if you want your between, we're talking about between dates, if you have an index on that, it's a lot cheaper to have some kind of sequential or range access on InnoDB or MyISOM. And if you truly need a random access, and it's always random, you're going to want preferably something that has a hash index. So it's another thing to think about if you're really getting to that level of optimization. Another thing, a lot of people, and MySQL actually recommends RAID 5 for MySQL databases. Really the question to ask yourself is how disposable is your server? If you have a lot of high availability, you probably are replicating to a slave, you probably can fail over at any time. Do you really need RAID 5 if you're doing that? Can you use RAID 1 or RAID 0+1? It's your decision certainly to make, but I've certainly when there are issues where it's like, we don't really have that many more transactions, but things are so much slower, we end up finding out that one of the RAID disks is dead. And so it's trying to write to the dead RAID partition, it can't do it and whatnot. So it's actually always a lot of really surprising when we go to a client and they're like, it's so weird, it's so slow, it's not like this. And we're like, is the RAID disk dead? And they look at the machine like, wow, how'd you know? And I'm like, really, it's the only other reason why writes would get randomly slower. So again, check your RAID stuff. Do you really, if you have such a highly available MySQL setup, which you can do you really need that kind of RAID? And the answer may be yes, and the answer may be no. We talked about temporary tables before, which are tables that got too big for memory and wrote to disk. And you can actually check those. These are the status parameters, created temp tables, created temp disk tables that we talked about, that I showed you earlier. So again, if MySQL is slow, it's probably because a lot more stuff is happening on disk than you think. So let's talk about disk I/O. When does stuff write to disk? Well, when you change data. If you change data a lot, you might want to start batching changes. If you have a lot of inserts, you can do them all at once. If you can do insert, you can do them all at once in a batch, or you can use something called insert delayed, which basically waits until you get a batch of about 100 or more and then applies them all at once. But instead of waiting, if you have a, PHP or whatever, it's not going to wait until that whole thing is batched. It's just going to say insert delayed, and MySQL says, thanks, I'm putting it in the queue, and you come back and you do your own thing. And you can also do batch deletes, which is another thing that's recommended. When you delete from a table, it's going to, if it's MyISOM, any change or update for MyISOM will lock the entire table. Any change for InnoDB only locks the row you're changing. With one slight caveat, when you're inserting something with an InnoDB auto increment, it will lock the whole table for a very short amount of time that it needs to say, what's the next auto increment, I'm grabbing it. Which is a really tiny amount of time, but if you're doing it a million times a second, you can end up having locking problems. So every time you change the data itself has to change. Probably indexes have to change. If you're, say, inserting a row, any indexes have to be changed, and B-tree indexes have to shuffle around. They might have to be rebalanced. And binary logs, which are the change logs, most people have those enabled, they have to be written to. If you also have any other logging happening, that has to be written to. If you have triggers on a data change, that gets done. There's a whole lot of stuff that happens. There's also memory buffers that write for InnoDB. You basically have an undo buffer and a redo buffer. And with InnoDB, it writes the binary log, and then it flushes to the disk eventually with the data. So there's a whole lot of disk I/O going on when you do one update. One thing that we recommend to do is to have a separate disk for data and for backups or logs. So your binary logs have a different disk. And this way, you're always writing to your binary logs on one disk and you're seeking in one way. And when you're writing to your data indexes, you're seeking on the other disk. So I think that's about it for disk I/O. Obviously, faster disks mean faster, and sometimes the solution is you need to get a faster disk. We were talking earlier, a gentleman came up to me before and was asking about something like master-master replication. Well, with that, it doesn't actually scale writes because all of the writes have to happen to both masters. So you're not actually saving any write mechanisms because they have to do that, and you're not saving any of this disk I/O when you do that. You can read scale because you don't need to read from all the machines, you only need to read from one data set to do that. So the network. A lot of times the bandwidth is the network. If you have a lot of data going back and forth, a lot of times query optimization, it's not easy. SQL is a declarative language. Most programmers are used to a functional language or an object-oriented language. It's very difficult to think in sets. With SQL, you really want to think in sets of data. And how do you intersect this set or union this set to get the data you want? When you think in functional ways, you start thinking and getting things like, oh, well, first get this information and then compare it to that information. And that leads to a lot of things like subqueries, which don't optimize very well. So sometimes what developers do is just say, just give me all the data, and I'll just, use Perl to change it around, or I'll just use, regular expressions in PHP to figure out what I really want. But the more data you send back and forth over your network, the longer it's going to take. So there's kind of a balance between, how much work do you have the database do versus how much work do you have, say, the web server do, or whatever your application is. How much work, do each do? Because databases are really good at sorting and computing and comparing, but you also don't want to overload your database. So, you can say, let's say you're getting, reports of sales for each state, in the United States. There's 50 states, right? Puerto Rico and Guam, nobody buys anything there. Woohoo, you're still awake. Okay, thanks. Nobody laughed at size matters, but, talking about Puerto Rico and Guam like they don't matter, everyone's giggling. One thing that you can do is you can say, well, okay, I'm just going to go back and forth 50 times and get that data, because it's too slow to do the whole United States and group by the state. Well, the problem is then you're going back and forth 50 times and you're sending the data and whatnot. So you can say, well, it's the same amount of data, but you have to, if you're using, PHP without connection pooling, then you're connecting 50 times and coming back. And, what's the right kind of balance there? Maybe you can kind of get some of the data and flush the web page so it comes up again. There's really no easy solution. It's that art versus science thing. But there can be, with network traffic, you can say, well, you're doing more work in the application than you should, and so you're sending more data that you then just throw away. And obviously for network traffic, there can be latency on network traffic. And, how much CPU do you want to use on your machine or the client machine, the end user machine, versus how much CPU do you want the database to use. One of the things that, one of the ways you can save network bandwidth is to use a key phrase on the insert command to say insert, insert into table, value, here's these columns and these values. What you can say is instead of, so let's say you have, a user and they go to change their password, but maybe they never had a password to begin with. So instead of saying, well, what was their password, let me select their, password probably a bad, analogy, but instead of saying, let me get it, and if it's different, then change it, right? That's actually two queries, so you're going twice across the network. If you use insert on duplicate key update, what happens is you say, okay, insert into it, and if that key value, if there's already a unique key on that, and it already exists, then just update the fields, right? So, if, user Sheeri already exists, just update her fields to say, okay, now your address, So that actually saves tons of time when you use that, if you have that kind of thing. And there's a lot of places where you kind of want to say, okay, if it's not in the table, insert it, and if it is in the table, update it. And that's exactly what insert on duplicate key update will do. So I said size matters before, but so does performance, as we all know. So you guys, you're not laughing at these jokes, but you laugh at, Guam and Puerto Rico. It's okay. Part of it is choosing the correct table type. So we talked about MyISIN before. It locks on any kind of update. It also has exact statistics. So every time that there is an update, it redoes its statistics, its indexes, its analysis, its data length, all that stuff. So it takes longer, I don't know what I touched, but it takes longer to actually update in my ISOM, and it locks the table. So that's kind of two dangerous things, because not only does it take longer because it's doing the exact statistics, but it locks the whole table. You can use a concurrent insert data variable, status variable, system variable, global variable to allow concurrent inserts on my ISOM, and what it will do is it will just lock the end of the table, so you can add one, and then you can keep adding and adding and adding. But for the most part, my ISOM is really good for statistics and reporting, and if you have a lot of transactional stuff, you probably want to use EnoDB. The other thing my ISOM is good for is having a full text index. Now again, much like the query cache, the full text index is something that kind of does something if you have a little bit of a need, but if you have a huge need for like a full text index, you probably want to use like Sphinx or Lucene. So again, you have to think of what do you need to do in the database? What do you want to do in the database? What is the database good for? If it's good for that kind of index, then sure, go ahead, use it. But at some point, you might want to think about using a different technology that's specialized for it, much like the query cache versus memcached. Again, with full text index. Full text index is great for what it is, but you might find that, if you're indexing blog articles with words, that's something that Lucene is better for. The black hole storage engine. This is also known as the dev null storage engine. And you might be thinking, it's every database administrator's dream, let me tell you, because there's no problem. Remember how I talked about data length being really small, and it's really quick to query these tables, and it's all optimized, it's wonderful. The reason, actually, black hole tables are really, really useful, because a lot of times, say you have, people making connections, and you want to save every time somebody clicks a button on your page, you want to save what they clicked, and what page they were on, and what page they went to, and all that kind of stuff. Well, that's pretty much used for reporting. You're not going to look at that right away. So what you do is, on your master database, you have that be a black hole table, and then you have that replicate to a table that's not black hole. Let's say it's my ISOM on a reporting database. And so then what happens, yeah, I see that. It's actually really cool in that regards. It's a table that has nothing in it, and yet it's so functional, it's so useful. You can do that for, some people they'll have like a sessions table that's very high active and high write, and it'll be like a memory table and whatnot. And every 2 minutes, they kind of like archive it off, and any connections that are now defunct, they get deleted out of the table, and any connections that are still there get put back in. But it's really useful for that kind of archiving.
In what ways is that more useful than just writing, all that plugin and stuff to a separate instance?
In what ways is that more useful than writing all that stuff to a different instance of MySQL? Well, you don't need a separate instance of MySQL. It's not actually it's the same benefit in a way. If you're just writing it to, say, the reporting instance, one benefit is you get data consistency. So if you have, if the user, like, say, logs in and you have that sessions table or something, and they click a button, as soon as they click a button, if something else happens, you have that kind of point-in-time consistency. But yeah, that's another way to do it, is to write to a different server. Again, once you start doing that, though, you end up having to work with the development group and whatnot, and change the query and change the database handle to go to this database instead of that database. It can get complicated. But that might also be the best thing to do, right? These things need to go to reporting instance. These things need to go to my data instance that I'm going to use right away. So again, it's just another way to do it. Merge storage engines are basically my ISOM storage engines, but they were partitioning before MySQL had partitioning, which it now has in 5.1. And basically what you can do is you can have a merge table as a wrapper table. There's nothing actually in a merge table. It's just a it's a table definition, and you have normal columns and default data types and all that kind of stuff, and indexes that you might have on a table. And what you can do is you define that table, and then you define which tables it wraps around. And so they have to be the exact same schema, but you can say, okay, here's this table user clicks. And that is actually a wrapper table for user clicks January, user clicks February, user clicks March, user clicks April. And so you can partition the data in that way to have smaller files that you're looking through, all that kind of stuff. Memory tables we talked about before, they're in memory, they're much faster. Things like a session table where it doesn't matter so a memory table, when the server restarts, everything goes away. So it's useful for things that, are kept in memory, say a sessions table. A sessions table is a very high write table. You're probably not scanning through every single person who has a session. You're probably really doing more random access reads than sequential reads. So it's a useful application for a memory table. The archive table is, it's again a MySQL table, but it's a read-only table, and you can only have one index per, it's not true. It is a write table. You can insert, but you can't update or delete. And basically it's for archiving. So if you have your Apache logs going to, a table, it could be an archive table. There are some limitations. Again, only one index is allowed, and you can't change the data. But it's really good for auditing and logging and stuff. The NDB table type cluster has a lot of limitations. Basically the data and indexes in 5.0 need to fit within memory with some certain caveats. Basically, the data indexes need to, with cluster, it's a highly available architecture. And you have different groups, and each group has, if you have two groups, each group has half the data. And each node in the node group has the same copy of the data. So if you have, say, 4 nodes in a node group and 2 nodes, that's 8 instances. And 4 of the instances will have half the data, and the other 4 will have the other half the data. And so basically, half the data needs to fit in memory. That's how it works. However many groups you have, it's 1 over number of groups amount of memory. And they use in-memory tables, so there are some limitations of the size, and with a memory table, if you have a variable character length, it's still actually a fixed width. So if you have varchar 100, it's actually going to allocate 100 characters, whether it's 100 bytes or 400 bytes or anywhere in between for each field, even if the field has 1 letter in it. So again, you want to choose the correct table types. With replication, you can actually have a master table that's 1 table type and a slave table that's another table type. Totally okay. That's kind of how the whole black hole thing works. It wouldn't work really well if you just kind of had to insert it into a table and then never do anything. Unless you just wanted it in the change logs, because it will insert it into the black hole table and say, yep, nope, it went fine, and write it to the binary log. So query optimization is a huge, huge thing. The query optimizer in MySQL works differently from the query optimizer in SQL Server and Oracle and SQLite. There's probably a query optimizer in SQLite, but who knows? So one of the things to use is to use explain. Let's see. Yeah, I'm not going to go into how to use explain, but there are some good pages on it, and I happen to have links to them right here, which are also in the blog post. So there's the MySQL manual on how to use it. There's also a little explain diagram. Let me open up those pages because they're useful. Here's the explain manual page and the explain cheat sheet. And so basically there's, well, yeah. I haven't really done very many queries, but we'll actually get to using explain. So if I use Sequila, which is the sample database, explain, select customer ID from customer. And basically what this gives us is about 10 rows or so of information. Select type, here's the table we're using. Type is actually the really big thing. This is the data access strategy. And what the data access strategy of index means is it does a full index scan. There's other data access strategies which are on the explain sheet, but I probably need to zoom that in. So here's the type. Zoom in once more. There we go. Can you guys read that? Yes? Kind of. So this is actually from fastest to slowest. So the fastest data access strategy is called system, and basically it's a system table that has 1 value in it. So obviously it's really easy to figure it out, right? Where the slowest one pays all, does a full scan of the table, I showed you index, which does a full index scan, which might be, say, a B tree structure. Things like full text, equality reference. There's one row from this table to compare to each other rows. Again, you can read about it in the manual page here, Optimizing Queries with Explain, which I've linked to, and it actually explains, here's the type, so system, it does all of that. Once you've actually kind of used it a little bit and just need like a little refresher, the cheat sheet is actually pretty useful for saying, oh man, is a royal flush better than a straight flush or not? That's kind of your cheat sheet. So yeah, query optimization. So one of the things that query optimization actually does for you is, here you can see that this table type is customer. It's actually doing a full index scan, and in order to do a full index scan, it actually needs an index. This is the name of the index that it uses. The length of the key is 1, which is very small, and it actually examines 541 rows. That doesn't mean how many it's going to return, that's how many rows it examines, I believe. I can check that. I might be wrong on that. And the extra here is using index, which is a good thing, because it means it's using an index. Some of the extra values are not so good, like using file sort or using temporary table. Using file sort means it has to do an extra sort after it's done, whatever other stuff it's done, joins or whatever, it has to do an extra sort through the data to get it back the way you wanted. Using temporary table means it's using a temporary table, things like that. So extra, there could be good things in there, there could be bad things in there, could be neutral things in there, just letting you know, hey, I'm using something. So one of the things, MySQL doesn't necessarily optimize some of these things perfectly. So if you do use these things, I'm not going to say don't ever use views or triggers or subqueries. But if you do, know what you're doing, use explain. Something about views is that they can be really tricky because you can have a view on it and it looks like a table. You do show tables and it shows you the view. You don't even know it's a view. So, a lot of people will use views for security reasons. A developer might not know they're using a view, write a query that's kind of simple, and as it turns out, it's actually a complex kind of query. And the good news is, I actually have an example for you. Because it can be really, really tricky. So, let's see. Web table, if exists, test.rentals per. So the Sequila sample database, Sequila is the name of the dolphin. The little MySQL dolphin's name is Sequila, which I don't remember the derivation off the top of my head, but it's I think it's Swahili for like dolphin or something like that. They had a contest to name it a while back. So the Sequila sample database is actually a sample database for a video rental company. So if you look at the tables, they have things like actor, film, customer, country, inventory, rental, and actually some of these are views already. So let's say we create a view. I'm just going to put it in the test database. Test.rentals, okay, you can't see that. Rentals per day as, and this is how you create a view. Select count star date of rental date, because it's actually a date time, as business day from Sequila.rental group by business day. And what this does is this gives you a table that's an aggregate of rentals per day. How many rentals per day? So we're basically doing a count per day of how many rentals were made. So I'm going to create that view, and that was a pretty good example because I didn't get any errors. Now, if I wanted to, do something to get stuff back, I would say, select star from, or I would do, select star from, I don't like to use select star because it's really bad. I never actually save a query with select star. I'll always put what it actually is. So, explain select star from, let's see, what is it, test.rentals per day, right? Let's say I want where business day. a certain day, right? Or business day equals, I don't know, 2005, 08, 01, August 1st, 2005, because that actually has some data in it. So we do that, it took 0.77 seconds, and there were 671 rentals on that day. That's pretty good. That's probably before like Netflix really kind of interfered with the whole Blockbuster thing. But now let's do an explain of this, and let's see what it has to do, right? This looks like a pretty, you know, if you didn't know that this was a view, you'd be like, yeah, that's a pretty simple query. I'm just selecting stuff for the business day, right? But because it's a view, you actually end up getting this derived table. And you would say, what is it doing with the derived table? Like, why can't it just, it doesn't use materialized views. It doesn't take a view and make a table and then just select from that table, right? It's using a derived table because what it's doing is, if we can scroll back up here to this create view, what it's doing is it's actually saying, right, select count star date rental date as business day from Sequila.rental group by business day. That's actually a subquery. And then the outer query is, you know, select star where that business day is, you know, August 1st, 2005. So you actually have this complicated subquery that you would never write in a million years. And, you know, it's doing a full table scan on, you know, 41 rows of the derived table. It actually has to, like, materialize the table every single time you run this query. Now, this is just a query of how many rentals per day there were, right? The better way to do this would say, well, rentals per day, yesterday's rentals aren't going to change. I can't go back in time and change yesterday's rentals. So the better way to do this would be to have some kind of an aggregate table where, you know, every day at, you know, midnight 05, you say, let's fill in this aggregate table with the number of, you know, rentals we had, you know, maybe some other statistics or whatnot. But you can see how even a very simple view with a simple query on a simple view can kind of get complicated because, you know, at this point you've got 15,000 rows, and for each of those 15,000 rows, you're doing this full table scan of 41 rows. So 15,284 times 41, you're actually examining over 500,000 rows for that simple, you know, 15,000 query. Now, if you did it with an aggregate table, you'd have an index on, you know, the day, and you would examine like one row. The subqueries, you know, some subqueries are better than others. A dependent subquery is not as good as a derived table, because a derived table, it materializes the table. A dependent subquery, it materializes the table anew for each single row in the outer query that matches. So it can get pretty complex. Sometimes explain, you know, isn't perfect, and it'll show you, you know, if you just you multiply the number of rows, sometimes it doesn't actually give you the sense of, you know, how far apart things are in an index, right? So if you do a sequential scan of 10 values, that's going to take a lot less time than a random scan in a B-tree index of 10 values. But it's still going to say, I've examined 10 rows in the index in the explain. So, let's see. Know what you're doing with limit. A lot of times, you know, you have like some forum. Oh, do you have a question? No, you're just, that's good. A lot of times if you have, you know, say forums, bulletin boards or whatever, you get, or a blog, right? You get the last 10, you know, titles or whatever, and you put them up on a thing. You know, for the next page you get, you say limit 10, 10, limit 20, 10. The way MySQL works with limit is that it has to retrieve all of the information up until the point you want it to stop, and it throws away anything else it doesn't use. So if you say, okay, limit 0, 10, it gets the first 10 rows. If you say limit 10, 10, what that does is it will return the second group of 10, right? The first group of 10, it actually has to retrieve and throw away, which is great, except when you get to like, oh, show me like the last page, which is, you know, limit 5 million, 20. And now it has to retrieve the entire table just to get those last 20 results. A better way to do it, and anyone that wants to take this model, run with it, make $1 million, I don't even need the credit or anything, just, you know, well, you could like give me like, you know, hey, Sheeri thought of it. You don't have to give me the money though. A better way to do it would be to say, okay, let's say you want 20 items per page. Cache, when you get to 20, cache that page. You know, and maybe cache it up to say 25. And when you get 25, you get the 26th one, that becomes a new page. Right? So the last page is always the same last 20. because that never changes. Again, much like yesterday's values, that never changes, right? The middle, right, middle 10,000, item 10,000 to 10,020, that's not going to change. So you just kind of have something where it kind of builds the pages, and then, if you want, you can actually just build the HTML page, right? You don't even have to go to a database at that point. You just cache the HTML page. I think it's a better way to do it than to use something like limit. Other database systems do that kind of limit a little better, but that's also the way they work. Stored procedures, much like triggers, stored procedures, you have to know what you're doing, because if you're doing 5 different actions with one stored procedure, maybe there's writes, maybe there's calculations. They're also compiled per thread, which means that if you're using PHP or something and you're connecting, or Perl, you're connecting once, you run a stored procedure once, and then you exit, it actually does the work of compiling it, and use it once, and then you exit. So there's extra work there, and you're not actually saving yourself anything. So, you might be using stored procedures for expediency, for having multiple applications be able to use the same thing, and that's fine. But just, again, know what you're doing, know what the consequences are. I'm going to talk a little bit about indexes. Indexes are great. They're faster if you have them. Reads are faster. Writes are slower, because you have to update, that index structure. We talked a little about which storage engines have which structures. There are no materialized views, and for the same reason that there are no materialized views, is the reason that there aren't indexes on a function of a field, right? So if you have an email address field, you can't have an index on the last X characters, right? You can only have an index on the first X characters. So if you try to, say, select, the last word or the last 3 characters of a field, it actually can't use that index. And then we talked about the overhead versus utility. So the selectivity of an index. The selectivity of an index is how different the variables are. It's related to cardinality. The more selectivity you have, the better. A unique index has a selectivity of 1, which means that every value is a unique value. Did I say that was a primary key index? I meant to. I don't know what I just said. Anyway, unique keys have the most selectivity. There are keys that don't have a lot of selectivity, like flags, on or off, active, non-active, red hair, blue hair, whatever. Those aren't really good to search on. Because what happens is that there is a magic point. So the way indexes work, let's take a B-tree index. You have the values in the index. You say, okay, let me search that. And if it's not a covering index, as in if not all the variables you want that you want to retrieve are in the index, it actually has to go to the data row. So there's overhead in going to the index and then going to the data row. And the point at which that overhead becomes too much of going, instead, why not just go to the whole table and just search the whole thing, is at about 20 to 30%. So if you're searching on, where the status is inactive and there's, a very small number of inactive people, that's actually a very good search. If you're searching among the active people, that's a bad search. It's going to take longer because it's just going to do a full table scan. So if you do not want more features because you think it's bloated and whatnot, and you're like, oh, I don't need these triggers and whatever, you want to look into Drizzle, which is a MySQL fork. It's drizzleproject.org. And that's it. If you want more features, then you're just going to have to wait or submit patches yourself. So why else do you hate MySQL? Yeah. Microphone, please. Thank you.
Because replication keeps failing, and it's hard to communicate to developers what they ought to do to make it not fail. Okay. So the question is, replication keeps failing, and how can we communicate with developers? Well, why is it failing? Is it failing because developers are going into the slave and putting stuff in, or because it's not always the developer's fault when replication fails? So sometimes it's usually queries that do one thing on the master and something different on the slave, or queries where on the master multiple threads are running things in parallel and one of them takes a long time so the slave gets backed up. It's all sorts of things that are happening on the master that end up being different on the slave.
Right, and there can also be data value differences because if there's like a packet lost, MySQL might not notice there's a packet lost. Well, you know how you said before, what's the value of having like a black hole table instead of like just saying, oh, the code should go off and do something on another database? There's value in not having that level of transparency, to developers, where you can say, okay, there's just one IP that you go to, and that IP you can use actually MySQL proxy to separate reads from writes and use a load balancer for that. How to communicate between system administrators, database administrators, and developers is a topic that is beyond the scope of this subject. But I mean, you can tell them, hey, it keeps breaking. A lot of problems usually can be solved by having a test infrastructure and saying, okay, this alter table is going to take 20 minutes, so our slave is going to be out for that 20 minutes. It's going to be behind for that 20 minutes. And discussing the ramifications of that, and not letting the developers do changes on production systems. That's another one.
No, it's usually the code. The code has queries. Some of the queries sometimes make replication fail, and nobody really knows which of those are going to do it, and it keeps happening.
Do you end up finding them once they do? Because one thing that you can do is do a query review, which is similar to something like a code review, but what you do is you turn on the general log on your development system and you look at all of the new queries that are coming. You kind of have okay, I've seen this query before, I haven't seen this query before. In an ideal world, there would be some kind of magic program that did this for you. We're getting closer and closer. MySQL has a query analyzer that goes along with their enterprise product. So that is a difficult problem. One way is to make the architecture transparent. Another way is you can make the slave read-only.
Yes, we definitely always make slaves read-only, but at two different sites, this was always a recurring problem. That stuff, MySQL 5.0.
Yeah, again, it's hard to prevent people from doing stupid things. It's hard to prevent people via code of doing stupid things. You can take preventative measures to do that. If developers keep making code that has problems, then you need a DBA to step in and say, let me look at your code, or don't write a query, I'll write the queries for you. It's difficult. It's like having a developer configure Apache. They usually know what they're doing, but sometimes they can really screw stuff up. Because they're not Apache developers, it's not anything bad. I'm not going to be like, oh, developers are evil. They're not. They are really smart in what they're really smart in. You don't want to see my procedural code. You really don't. It's really bad. But I'm a DBA, I think. So it's a difficult thing, and it's something that, you might have to take to management and say, we really need to review all of the new queries that go in. Or we really need to be in on the development meetings, because we need to, are they creating their schemas too? They're probably creating their own schemas. They create them on development and they give it to the DBA and they say, okay, I need these queries, I need these tables made on production. And you're like, when did you become a data architect and how come I wasn't in that meeting? So it is more of a user issue. Again, you can do some kind of technological stuff like read-only, and that the read-only parameter will make it so that the only users that can write to any tables in that database are super users with the super privilege, which includes the system user, which does replication. It's difficult. I wish there was an easy answer. But that's not why you hate MySQL, it's why you hate developers, right?
It's MySQL because it's really, really hard to come up with any process by which people can write their queries that work on the master, and you know that the replica will work.
Well, and there are problems actually. One thing I didn't get into is replication unsafe functions. For example, if you've ever looked in the binary logs, you might notice that it sets the auto increment ID. It'll set the timestamp, but sysdate, the sysdate function, doesn't use timestamp, right? Now uses timestamp and current timestamp uses timestamp, but if you use sysdate, the function sysdate, it actually uses the system date. So if you have two different times on the system, because say they're in different time zones and they're not using the TC, you actually can get different values for that. And that is a problem with MySQL. You can go to the manual and see which ones are replication unsafe. Go through the binary logs and search for those things. There isn't an easy way to have MySQL say, oh my god, that's replication unsafe and you're using binary logs, don't do that. It actually does that in some small cases, but not regular functions. It's usually when you're, using, views and triggers and whatnot. It'll error on those things, but not in just regular functions. Any other feedback? You all now love MySQL? I'm out of a job. Okay, yeah?
Yeah, I have a question. I don't know if you're the person to ask this, but a question about roadmaps and various versions of MySQL, or MySQL, excuse me. I heard rumors that due to various corporate mergers and purchases by Sun, Oracle, etc., that 5.1 was getting delayed indefinitely, and wait till 6, and until you said that 5.1 was forthcoming really soon, I had no idea.
Yeah, no, it's coming really soon. I mean, that's basically, I think we're pretty much out of time. That's basically, I think people are perpetuating that rumor on the fact that 5.0 has been out for 3 years and is actually being end-of-lifed at the end of the year. And it would be really silly to have the end of life of the current working version without having a new, generally available version. So I think people are just like, oh man, we're never going to get this. And that turns into, oh my god, we're never going to get this. So, yeah, not everything you read on Slashdot is true. But yeah, no. Yes, and except for the fact that Emacs is the best editor except for VI. Anyway, thank you very much. Feel free to come up with questions to me afterwards. I'm going to pack up my stuff and go to the back in respect to the next person who's talking. Thank you very much.